Ever wonder why some AI answers feel too polished, like they're checking boxes instead of really understanding the question? It's like a student who memorizes answer patterns but doesn't grasp the material. That's the problem we're tackling today: reward hacking, and how a new approach called Crome is teaching AI to focus on what really matters. So here's the deal: AI models learn from human feedback, right? But sometimes they pick up on tricks, like favoring longer answers or fancy formatting, instead of actual quality. These are called spurious cues, and they're a big deal because they make AI systems misaligned with real human values. Enter Crome. Think of it as a smart teacher for AI. Instead of just relying on existing data, Crome creates its own training examples to teach models the difference between real quality and fake shortcuts. Here's how it works. First, it identifies causal attributes, the real drivers of quality. For example, in a science question, that's accuracy and clarity. Then it generates two types of data. 1. Causal augmentations. Imagine taking an answer and tweaking just one thing, like making it more accurate or less relevant. By comparing the original and modified versions, the AI learns to care about the right stuff. 2. Neutral augmentations. These are pairs of answers that change irrelevant features, like word count or emojis, but keep the core quality the same. Training on these teaches the AI to ignore distractions. The magic: Crome doesn't need to know what the spurious cues are beforehand. It focuses on the causal ones, and the rest falls into place. And the results? Crome outperforms traditional methods by up to 5.4% on benchmark tests, with huge gains in safety and reasoning tasks. Even when asked to pick the best answer from a pool, Crome stays reliable, proving it's not just good at common cases, but also tricky ones. Why does this matter? As AI becomes more integrated into our lives, we need it to align with real human values, not just surface-level tricks. Chrome's approach is a big step toward building AI that's not just smart, but wise. Let's break it down further. Imagine you're grading essays. What makes an answer great? Clarity, accuracy, relevance, those are the causal attributes, the real deal. But then there's the noise: how many paragraphs there are, or if the font is bold. Those are spurious attributes. They look important, but they're just distractions. Here's where it gets clever: counterfactual generation. Think of it as a what-if game. Take an answer, tweak one real factor, like making it more accurate, and see how the AI reacts. If it still prefers the original, it's clinging to surface-level tricks. But if it switches, it's learning the right lessons. But wait, spurious features often hide in the data. Changing one real factor might accidentally shift the fake ones too. So researchers use neutral augmentation. Here's the twist: they throw in irrelevant queries. Like asking the model to rate answers about space exploration, then suddenly switching to cooking. If the model still favors the same answer, it's because it's focusing on real quality, not shortcuts. Finally, they filter out the noise. Not all examples are useful. They keep only the ones where the model is unsure or wrong, forcing it to learn from its mistakes. But here's the catch: Chrome's theoretical models are simplified. Real-world AI is messy. The math works in clean scenarios, but in the real world, LLMs behave in complex, unpredictable ways. That means Chrome's guarantees are more like a roadmap than a guarantee. And scaling this up, it's computationally heavy. Generating all those causal and neutral examples takes a lot of processing power. Imagine training a model by rewriting thousands of sentences to test every possible twist: costly, but potentially powerful. What happens when Chrome hits a new kind of trick? Like a spurious pattern no one anticipated. The system struggles. It's great at handling known biases, like rewarding verbosity or formatting. But what if a model starts favoring answers with a specific emoji? That's uncharted territory. The researchers say we'll need more flexible tools, maybe even abstract invariance learning, to tackle these surprises. And here's another hurdle: LLMs aren't perfect at creating counterfactuals. These are like hypothetical scenarios, e.g., what if this answer were shorter? But if the AI messes up the rewrite, it introduces noise. It's like asking a student to solve a math problem, but letting them use a calculator that sometimes gives wrong answers. The results are still better than before, but there's room to improve. This work sits at the crossroads of several big ideas. From RLHF, reinforcement learning from human feedback, to causal inference, researchers are racing to make AI align with human values. Chrome joins a growing family of tools that use data augmentation, like creating fake examples, to train smarter models. But unlike others, it leans on a causal graph to structure these examples, ensuring the model learns the right lessons. So where does this take us? Chrome shows promise, but it's just one piece of a bigger puzzle. Future work might focus on making these systems more efficient, adaptable, and resilient to the unexpected. After all, the goal isn't just to build smarter AI. It's to build AI that understands what we value, even when the rules get tricky. Next time you see an AI answer a question, ask yourself, is it just copying the right format, or is it actually understanding the problem? Thanks to work like this, we're one step closer to making sure the latter is the case. Want to dig deeper into how Chrome works? Hit subscribe for more breakdowns of cutting-edge AI research. Thanks for watching. If you want to dive deeper into how AI learns from mistakes, hit subscribe, because the future of smart machines starts with understanding what really matters.